What we have here is a special limit type, and in fact this is going to be the last of our considerations for the first exam. This is the last of our consideration of the limit types for our particular course. I want to sort of make a sketch of an just a rough outline of the procedure here. So when evaluating a limit, so the first thing you try, number one, first thing you try, substitute and simplify. If that gives you a result, you're finished. All right. Now there are two things that could go. Well, let's see. There are a couple things that could occur. If you get an answer, if this is a number, then you're done. All right. Another possibility is direct substitution gives 0 divided by 0. And we've talked about what to do here. Do some algebra, do some trigonometry, try to obtain the special limit properties we have. So roughly speaking, this is do algebra or trig, simplify, try again. Well, there's one other item we can consider now, and that is, what if we get a over 0 where a is not equal to 0? What if you get, I'm going to write this conceptually, what if you get non-zero divide by 0? This is the last scenario where we will consider. We've not considered that yet. So what happens if direct substitution, substitute, simplify, if you get an answer, you're done. If you get 0 divided by 0, do some algebra, trigonometry, simplify, try again. But what if you do direct substitution and what you get is something like 7 divided by 0 or negative 8 divided by 0 or 1 divided by 0. You get a non-zero value, divide by 0. What we are going to do is treat this as a special separated case from all of this work. All of this work is essentially based upon algebra, trigonometry, the properties of limits. All of this is essentially, it's hard and fast, theorem proof. We have properties to apply. And this is essentially, roughly speaking, we say this is extremely mathematical. What we are going to do here is not, strictly speaking, precisely mathematical, perfect. This doesn't pass really particularly rigorous muster. What we are going to do is a short little stopgap patch to cover the scenarios that we will encounter this semester. It is possible that as you go upward through the coursework that you will encounter circumstances where this little stopgap patch method that I'm discussing here will not suffice. It won't work. When that happens, you will pick up some new techniques, some other ideas on how to handle those limits. For us, this is extremely narrow sort of circumstance. For us, for now, for the types of items we will consider, we will handle this in a separate, again, it's a separate, apart from the others, a little patch to cover up this particular scenario. It is not, strictly speaking, mathematically rigorous. It won't survive proof, theorem, muster, but it will get us over the issue at hand. And for the problems that we will consider this semester, this will be sufficient. So that's probably about as much disclaimer or proviso as I've ever given on any particular topic, and that's why, because this isn't really, strictly speaking, mathematical. So what we'll do now is talk about what happens if you get non-zero divided by zero. Let me start this, say at the very start. I guess I'll call it a technique, the procedure that we use here. If you try this procedure in either of these two scenarios, it is not correct. Strictly speaking, it's not really even correct in this scenario, but we're just using it as a stopgap measure. If you use this procedure on either of these two scenarios, it is off base. It is not accurate, it is not used, it's wrong. So this, what I'm going to discuss here, applies only to this specific scenario, only for the problems that we're going to consider this semester, and only as an unofficial, non-rigorous stopgap, in the pinch, patch over this particular problem type. So that's what we're coming up with next. So consider the limit as x approaches, let's say 2, of the function x plus 5 over x minus 2 quantity squared. All right? What's always the first thing you try? First thing you try, substitute simplify. So if we try substitute simplify, substitution produces 2 plus 5, 2 minus 2 quantity squared. That's 7 over 0. This special subcategory, this one individual special scenario, is really the only time I need to see you write this out. In this scenario, you need to write this out, and so this lets me know that you know we're in this special scenario. All right? This is non-zero divided by 0. And now what we're going to do is a special little procedure that only applies in this setting. All right? So we will only use in this setting. So here's the deal. Where x is approaching 2, think of the number line. Here's 2, and the x value is approaching 2. Well, approach from the left and approach from the right. If you approach from the left, a number very close but less than 2, we will choose, for our purposes, simply choose a value 1/10 of a unit away from the value of a. So the value 1/10 less than that is 1.9. So what we will do is we will say, I'm not even going to put an equal sign because that's not what this is equal to. What we will do, we will use x equal 1.9, and then we must also approach from the other direction. If you approach from the other direction, the value 1/10 away from 2 is 2.1. And so we will also use x equals 2.1. This will never happen in any other scenario other than this. So if direct substitution produces non-zero divided by 0, I want you to write that. That way I know that you know we are in the special scenario. Then you choose a value 1/10 of a unit on either side of the value a in question. Now, substitute into here. Substitute 1.9 into here. We don't need the specific number, although you're free to write that specific number if you like. All we need to know is whether the numerator and the denominator are positive or negative. That's all we need. Now, for the record, 1.9 plus 5 is positive over. And then I have 1.9 minus 2 quantity squared. Well, that's a 1.9 minus 2 is negative 0.1, but quantity squared. It doesn't matter what the specific number is. All we need to know, here, I'll just continue in a column here. All we need to know is when I take this value, 1.9 minus 2, I get negative something. That number squared is positive. All right? Positive divided by positive divided by positive is positive. And here's what we may conclude from this. If direct substitution of, in this case, 1.9 produces positive divided by positive, which is positive, that means the limit as x approaches 2, now we've restricted our approach, restricted from the left, of x plus 5 over x minus 2 squared. This is positive infinity. Remember what we've talked about before is there are 4 scenarios in play. I'm going to steal some space here. There are 4 scenarios in play. One possibility is that we have the volcano function. Another possibility is we have the down the drain function. Another possibility is it goes positive infinity here, negative infinity here. And then the other possibility is negative infinity here, positive infinity here. And what we have just found is that as you approach 2 from the left-hand approach, it goes to positive infinity, which tells us as we're approaching from the left, it goes to positive infinity, which means it's not that, it's not that. As x approaches 2 from the left, it goes off to positive infinity. So this is one possibility. As you approach from the left, this goes to positive infinity. This is a possibility. So we know it's one of these two. I'll write these two up here because I'm going to need this space here in just a moment. So one possibility now is we have a volcano function. Another possibility is it goes to, another possibility is it goes to positive infinity here, negative infinity here. So these are the only 2 options on offer so far, or at this point. So to divide between those 2, we choose the approach from the right. If we approach x from the right, we're using 2.1. Again, substitute. We do not need the specific numbers. We have 2.1 plus 5 over 2.1 minus 2 quantity squared. All we need is positive or negative, not the specific number. 2.1 plus 5 is positive. 2.1 minus 2 is positive, and then when you square it, it also is positive. Positive divided by positive is positive. And so what do we conclude? We say that the limit as x approaches 2 from the right, we check the approach from the left, we check the approach from the right of x plus 5, x minus 2 squared. We have concluded that that's also positive infinity. As you approach from the left, it goes off to positive infinity. As you approach from the right, it goes off to positive infinity. And so now we know which of these 2 is actually the item we need. We know it's not this. We know this is the picture. And that's not what we're asked to find. What we're asked to find is the unrestricted limit. This is the limit as x goes to 2, irrespective of the direction of approach. This is the unrestricted limit. Well, the limit from the left is positive infinity. The limit from the right is positive infinity. If the left-hand limit and the right-hand limit agree, then the unrestricted limit agrees on that same value. And what we may write now, let me steal some space. What we may write now is this is equal to positive infinity, because the left-hand approach and the right-hand approach gave us the same value. If the left-hand approach goes to negative infinity, and the right-hand approach also goes to negative infinity, then the unrestricted limit would go to negative infinity, because they agree. However, if the left-hand approach goes to positive infinity, and the right-hand approach goes to negative infinity, then the left and the right approaches do not agree, and we would say this limit does not exist because the left and the right-hand limits do not agree. If the limit from the left goes to negative infinity, the limit from the right goes to positive infinity, then we would say the unrestricted limit does not exist because the left and right-hand limits do not agree. All we're after is whether this goes to positive infinity, negative infinity, or do they not agree? In which case, it does not exist. So that's going to be our technique. This is not official. It doesn't pass rigorous muster, but for the problems that we will consider, it will get us over this rough bit. So it's going to be a patch to cover up this special scenario. The only time you get to use this approximation 0.1 business is if we're doing this substitution produces non-zero divide by zero. In this scenario, I will expect you to write this out. That way I know that you have checked and you have this non-zero divide by zero, and then you may choose your values on either side of the value of A. So we'll rummage through a few more examples of this, and this shouldn't be too much of a hassle to pick up on. It actually works out fairly straightforwardly.